So what happens when we can no longer make everything come down to a number? What happens when the decision has multiple facets that we're trying to maximize or minimize? And what happens when you can't drop it into a formula, if you can't drop it into a decision matrix? Well, in that case, when we have a situation when we have to decide between apples and oranges, we have to take another approach. And this is more of a qualitative approach to decision making. There is not a formula. There's a rationale, there's a method, there's a way we're doing this, and there's a logic to what we're doing. But when we do this, there is not a right answer. What you'll do is we're going to take an approach called even swaps, and what even swaps allows you to do is make a decision that reflects your personal decisions and your personal values, and be able to understand logically what you did and why you did it. So therefore, again, as most things, we don't know until we have hindsight whether it was right or wrong. In this case, at least we'll be able to explicitly understand why we made the decisions we made, why we made the trade-offs we made. So now let's go through the process of doing an even swaps analysis. And this is the same example that you have in the article. So you can read that and go through this. And I think going through this, both listening to me and reading it should give you a good understanding of what's going on. And this is all about a process. Okay, this is how you make a decision. It's not necessarily what the decisions you make are, but it's how you make a decision. So the first thing we need to do is put together a consequence table. Now again, this may look similar to the payoff table that we had previously, but it's not. It just has values for different things. So here we have a situation where an individual is trying to decide where they should locate their office. And they have 5 choices: Colden, Lombard, Baranof, Montana, and Pierpoint. So those are the 5 possible decisions, and we want to pick the best. We've also identified 5 different objectives that we're trying to either maximize or minimize. So if we look at commuting time, we're trying to minimize that. If we're looking to customer access, we want to maximize that. If we're looking at office services, we want to maximize that. Office size, we want to maximize, and monthly cost, we want to minimize. So what we've done is just taken the information and laid it out in the table. Commuting time to Colden is 45. Commuting time to Montana is 25. 25 is better than 45. So what we're going to do, this is the first thing we're going to do, is lay out the consequence table, lay out the data. Okay, we need to get the data first. We always have the GIGO principle, but in this case it's pretty straightforward. We put the data out there, and from there we start to do a few different things, and we'll do that in 1 second. So now we're going to take the information from the consequence table and we're going to rank order things. Okay, and in this case what we're saying is 1 is the best and 5 is the worst. Okay, so 1 is the best, 5 is the worst. So going back to the consequence table, we'll say the one with the shortest commuting time was Baranof, so that's a 1, and the one with the longest commuting time was Colden, so that's a 5. By the same token, if we look at customer access, the best was Montana, the worst again was Colden. We look at monthly cost, the lowest was Baranof, the highest was Montana. So we have now taken and rank ordered these different objectives. Now recognize, right, and this is really important, you cannot do arithmetic functions on rank orders. We cannot add these things up. I know some of you are going to try to do it. You cannot add them up. These are rank orders. How do you add tall and taller? These are just constructs, and we don't have an arithmetic situation here. These are just orders. So first thing we do, We rank order everything. Now what we want to try to do is, given this information, we want to see if this can help us make a decision on what is better. Which one of these might be better than another. So now that we've rank ordered things, we want to see if one or another is dominant over something else. That is there a choice which is clearly inferior to another choice? So in this case, remember, we're saying lower is better. So what we're going to do is we look across this and we find that we see differences, significant differences between Lombard and Pierpoint. Okay, you see differences between Lombard and Pierpoint. So if we look here, we see that Lombard has a value of 2 for the commuting time, which is the best. Pierpoint is 4. Customer access 2. Pierpoint is 3. Office services is 3. Pierpoint is 4. Here we're tied 3 and 3, and here we're tied 2 and 2. So if we look at this, we can see that on 3 items, commuting time, customer access, and office services, Lombard is superior to Pierpoint. On the 2 other situations, they're tied. Given the fact that it's superior on 3 and tied on 2, is there ever a reason why you would take the inferior choice, that being Pierpoint? That's the logic of dominance, because what we want to do is we want to try to, as we go through this process, we want to try to eliminate options, right? And we want to try to eliminate commuting time so we can come down to a logical situation. So now, given this, we would say that Pierpoint is clearly inferior to Lombard. Therefore, we can eliminate Pierpoint from our discussion. We do not have to worry about selecting this. We will reject this choice right now. So sometimes now we may have dominance, but it's not clear, or there may be certain items that are close, but we're really not sure what's going on with them. So we can have pure dominance, which we had between Lombard and Pierpoint. As you can see, we've eliminated Pierpoint, but we can also have practical dominance. So if we look here, and we're comparing, in this case, we're going to compare, let me get my laser pointer, we're going to compare Camden and Montana. So if we look here in terms of commuting time, obviously Montana is superior. In terms of customer access, Montana is superior. In terms of office services, it's tied. And in terms of office size, it's superior. Remember, we're talking about this, the lower number the better. However, the only thing where there's an issue is between the monthly cost, where Calden is superior. Now this may say, okay, well, so we really can't do that. However, remember, we've just rank ordered these things. We do not have a true distance between the different numbers. And if we go back and we look here, we see that the actual 4 represents $1,850 a month, and the actual 5 represents $1,900 a month. So if we're looking at that, we may decide, and this is up to you, but in my case, I've decided that the difference between $1,850 and $1,900 is basically a tie. So I can forget about this as a choice, as a deciding factor in this decision. Therefore, what am I going to do? I'm going to eliminate Calden, and I'm going to keep Montana. So this is practical dominance. And again, I had to go back to the consequence table to look at these. And again, this shows where the rank ordering is strictly in order. It is not something we can use mathematically, because $50 ain't going to make a difference here. However, it might have biased our decision. Okay, so let's take a look at this again. Take my laser pointer. So now we have 3 choices left: Lombard, Baranoff, and Montana. So now we get to the point where we're going to try to do a swap. That is, we don't necessarily just eliminate choices, we can try to eliminate objectives. So what we want to do is look at the rank ordering and find objectives that are fairly close together. And in this case, as we look at it, we find that the commuting time is 2, 1, 2. Okay? So if we made all of these the same, that is, if we made Baranow's commuting time too, we could eliminate commuting time as a decision variable that we needed to consider. So let's go back to our consequence table, and we have 25 and 25, and Baranow currently is 20. So what we say to ourselves is, okay, self, I'm willing to treat this as having a higher commuting time, that is 25. However, if I'm going to take a higher commuting time, what I want is greater customer access. So previously, as we did this, we had 80, 70, and 85. So I'm saying to myself, well, if I'm going to have to commute 5 minutes longer, I want 8 percentage points greater customer access. Now again, this is not set in stone. This is your decision. This is what you've decided. This is the trade-off. This is the apples and oranges. You've decided that if I'm going to commute 5 minutes more, I want 8% greater customer access. So we make that change right here. So we've made a swap of commuting time for customer access. Now if we do that, then this becomes these all become the same. They're all 25 minutes, right? Therefore, if they're all the same, we don't need to consider that in our decision calculus because it makes no difference. They're all the same. Now again, this isn't really happening. We're not changing the commuting time, we're not changing the customer access, but we're saying to ourselves in an effort to try to understand what's going on and try to follow the process that this is what would make sense to me. So this is the basis for your decision. Okay, so now we're going to do another swap. This one is a little bit more complicated, but it follows the same logic. So here I've said, well, let me see if I can get rid of office services. It seems like a pretty straightforward thing to deal with. So before we had ratings of 3, 4, and 1, or as we, let me get back to my pointer, I'm sorry. We're going to get rid of office services. So before we had ratings of 3, 4, and 1, right, which was based upon B, C, and A. And so we say to ourselves, okay, what happens if I make all the office services B? Okay, so in this case, what I'm saying is for Baranow, I want to increase the office services, and for Montana, I want to decrease the office services. So here, if we look at this, what I'm saying, if I increase the office services, I'm willing, or decrease the office services, I'm willing to, requiring that I either increase or decrease the rent. So what I'm saying here, if I went from C to B, I would be willing to pay $200 more in rent. It was previously $1,500, now it's $1,700. Over here I'm saying if I reduce the services from A to B, I'm willing to pay $100 less for services from $1,900 to $1,800. Now again, look at this. This decision from C to B I'm saying is $200. From A to B I'm saying is $100. Is that logical? You know, one might say that they should be the same, but in this case, this is my decision. This is what I've decided that it is worth to me. This is how I'm looking at this, trying to go forward with it. Again, is it right or wrong? No, but I know logically what's happened. So now if we do this, we have all of the office services listed as B. Therefore, it makes no difference in our decision criteria. Therefore, we can eliminate office services. So now, given the fact that we've cut down our number of objectives, it becomes easier to go back and look at dominance. So in this case, you know, given our new consequence table that we've developed, we have these ratings, the rankings right here. And if we look up, I'm sorry, again, I got to turn on the pointer. We have the new ratings here and the rankings associated with them. Okay, this is our consequence table based upon our swaps. These are the rankings based upon those swaps. And here we can see that in every case, Lombard is superior to Baranow. 3 versus 2, 5 versus 3, and over here on the monthly cost, they're the same. Therefore, following the logic that we've had up to this point, we say that Baranow is dominated by Lombard. Therefore, what will we do? We will eliminate Baranow. Okay, so now we're down to Lombard and Montana, but we still don't have it clearly laid out for us. So what we're going to do here now is we've decided we're going to do something with office size. We're going to trade office size against monthly cost. Okay, so what we had here is Montana had 950 square feet of office space, and let me get my pointer again, I'm sorry. So if we look over here, we see that Montana originally had 950 square feet of office space and Lombard had 700 square feet of office space. So what we're going to do is we're saying, okay, I want to increase Lombard's office space by 900 to 950 feet, so I'll make both of these the same. Therefore, office size won't matter. However, if I'm going to increase the office size, I'm going to have to pay more rent. So in this case now we're saying, okay, if I bring this up to 250 square or to 950 square feet, that's a 250 square foot increment, I'm going to bring the rent from 1700 to 1950. Again, this value right here, it could be objective, it could be subjective with this, but in this case we're saying 250 to 250 square feet equals $250. Therefore, we now have 950 for both of these, and we're able to eliminate office size. So lastly, we're going to look at the final analysis. This is our new consequence table that we have based upon the latest swaps. This stays the same. However, the monthly cost, as we talked about for Montana, has gone up to $1950 versus $1,800. Excuse me, for lump. No, damn. Sorry about that. I got to put the pointer on. I keep forgetting. So if we look here, these have stayed the same, but now we're reflecting the change we made in the previous slide, where now the rent for Lombard is $1950 and the rent for Montana is $1,800. Therefore, if we rank them, Montana would be 1, higher customer access is better. Lombard would be 2. For monthly cost, we would have Montana would be 1, Lombard would be 2 because it has a higher rent. Lower numbers are better. So in this case, we're looking here 1 and 1 versus 2 and 2. Montana is clearly superior to Lombard. So in this case, we now have come down to the point where we have made our choice of Montana being the best choice that we had given the information that we started off with. Again, someone else doing this might come up with a different result. However, you, using your analysis, using your values, have decided that Montana is the best choice. And if you go back and need to justify why you made a decision, you can see logically, step by step by step, how you did this. So again, this approach is totally about process. Do you actually trade these things back and forth? No. Right, but this is a model, this is a way of thinking about things that will help you make a decision where we have multiple objectives, where we have objective and qualitative data, and where it requires you to make decisions that are ill-structured. And this has been used in a number of different approaches. I mean, there's an article about how even swaps was used to pick a fighter drone for the Canadian Air Force. But anyways, again, we have total dominance. Montana's the best choice, and Montana is the best choice based upon a logical process that you employed.